Alright guys, so this is section 8, topic 5, and it's understanding piecewise defined functions. So first of all, let's talk about what a piecewise function is. So we know what a function is. One input, so let's just break this down. Function, one input has one output. So we put one domain in, one x in, and we get out one y. So a piecewise function is just a function made up of distinct pieces based on different rules for the domain. Okay, so we just have different rules or different pieces that make up sections of the domain. So the pieces of a piecewise function are graphed together on the same coordinate plane. So it's just pieces of different functions together on the coordinate plane. So then it says the domain is the blank or the x values. So the domain is the input or the x values. And then the range is the y values or the output. Okay? Since it is a function, all pieces must pass the vertical line test. So again, that means that all pieces have one input to one output. Okay, you already wrote that up there. You can write it both or either. So let's talk about a time that a piecewise function might be used in your daily life. So there's a lot of different times you might see this, but what you're thinking here is like maybe different sections of time, something different is happening. So one example of this would be traveling at different speeds. Over intervals of time on a road trip. Okay, so if you think about this, this would be a graph that might look like this, and then like this, like you stopped or you went more. So it could be steeper. It could just be different pieces that connect there. So traveling at different speeds. It also could be like getting paid hourly, minimum wage, and then getting paid an overtime rate. So anything that would change like that would be piecewise. So it's like you have two different things going on. So there could be like a quadratic, and then from there on, it's linear. Okay, so it's really just pieces of a graph put together. So we're going to look at an example of something like that. So consider the following piecewise defined function. So f of x is x squared minus 2 when x is less than or equal to 0, but 2x plus 1 when x is greater than 0. Okay, so each function has a defined domain value. These defined domain values or rules are these right here. Okay, so we have a function, but it's only this when x is less than or equal to 0. And it's only this when x is greater than 0. So x is less than or equal to 0 for the first function, and x is greater than 0 for the second function. Both of these functions will be on the same graph. They are the pieces of this completed piecewise defined function. So x squared minus 2 is graphed here, okay, and 2x plus 1 is graphed here. Now, let's notice a few things, okay? Let's look at a few things that are happening here in this graph. So this part right here is f of x equals x squared minus 2. And then this part right here is f of x equals 2x plus 1. So it's a quadratic graph and it's a linear graph. So one thing I want you to notice that's a little interesting on this graph is there is an open circle right here and there's a closed circle right here. So I want you to take a second. I want you to look at this graph, this open circle and closed circle, and look at these two inequalities. Why do you think one has an open circle and why does another have a closed circle? So think about that for a second. Okay, so we're about to answer that question. So I want us to look at some key features of this graph. So we're going to have to kind of turn back to this graph and then turn forward. But first it says the domain of the piecewise graph can be represented with intervals. We define the first interval as x is less than or equal to 0. The second interval would be x is greater than 0. Okay, so these are in set notation, not interval notation, and most of the time with a piecewise function, your pieces will be set notation versus interval notation. So they'll be written as x is less than or equal to and x is greater than. The graph is nonlinear when the domain is x is less than or equal to 0. So this graph is nonlinear for this section from here to here. So x is less than or equal to 0, everywhere where x is less than or equal to 0. The graph is linear when the domain is x is greater than 0. So everywhere where x is greater than 0, it's a linear graph. Okay? There's one closed endpoint on the graph, which means that the particular domain value 0 is included in that piece of the function. This illustrates the inclusion of 0 in the function f of x equals x squared minus 2. So that means that if I plug in 0, then the 0 value that I'm looking at, okay, because this has to be a function, the 0 value that I'm looking at is down here at -2. This is the value at 0. Now, remember vertical line test. If I were to do a vertical line right here at 0, it's still a function because this is not included. This is excluded. It's an open circle, just like when we graphed inequalities on a number line. This is an excluded value, so this included value, this is the only value that's the output. So one input does still have one output. So there's one open circle on the graph, which means that the particular value 0 is not included or excluded in that piece of the function. This illustrates the constraint that x is greater than 0 for the function f of x equals 2x plus 1. Okay? So it's not included in this one. So it's still a function because one input still has one output. So let's practice. Airheads, a trampoline gym, is open 7 days a week for 10 hours a day. Their prices are listed below. 2 hours or less is $15. Between 2 and 5 hours is $25. 5 or more hours is $30. The following piecewise function represents their prices. F of x is 15 when 0 is less than x is less than or equal to 2. 25 when 2 is less than x is less than 5. And 30 when 5 is less than or equal to x is less than or equal to 10. So let's sketch this on our grid. So this is going to be a specific type of piecewise function. It's going to kind of be a step function here. Now remember, the f of x is just like y. So if we had y equals 15, what kind of line would that be? Okay, that would be a horizontal line. So we're drawing a horizontal line at 15, and it's from 0 to 2. So from 0 to 2. Now, I have the line there, but I need to decide something. I need to decide what the end points of this line are going to be. This is 0 is less than x, which means x is greater than 0, but there's no line here, which means I need an open circle at 0. Okay? And then I need a closed circle at 2 because 2 is included in the 15. Okay? But when I go up to 25, 2 is not included. Okay? It's excluded from there. So that's an open circle. And I'm going over to 5. But 5, if you notice this less than, is also excluded. Also not included. So everywhere between 2 and 5. Now, I know my class enough to know that you're probably asking now, why wouldn't we just put it at 3? Okay, so if you think about that for a second, you could potentially be at a trampoline gym or trampoline park for 2.5 hours. You could potentially be at a trampoline park for 2.25 hours or 2 hours and 5 minutes even. So anything over 2 hours, if you're there for 2 hours and 1 minute, you're charged $25. That's why we have to have the open circle, because it could be 2 hours and 30 seconds and you would still have to pay 25 instead of 15. So the open circles here mean that it's all the way back to 2 hours, but not equal to 2 hours. If you're only there for exactly 2 hours, then you pay 15. Okay? Then we have 30. We have included here. So the 5 is included on 30. It's a closed circle. And then it's going up to 10, which is also a closed circle because of this equal to right here. Okay? So if you pay, if you're there for 5 hours exactly, then you have to pay 30, all the way up to 10 hours exactly. Okay? So f of x is a special type of piecewise function. So I told you this is a special type of function. Okay? This is called a step function. Okay? F of x is a special type of piecewise function known as a step function, which resembles a series of steps. Okay? Step, step, step. Step functions pair every x value in a given interval, a particular section of the domain, remember that's your x values, with a single value in the range, which is the y value. Okay, so this right here, you could label it as a step function. That's important. So, try it. Consider the previous graph in exercise 1. So we're still looking at this graph. How many pieces are in the step function, and are the pieces linear or nonlinear? So there are 3 pieces. And they are all linear. How many intervals make up the step function, and what are the interval values? So there are 3 intervals. And we can write these 3 intervals in interval notation. So the first interval is from 0 to 2. It's non-inclusive of the 0, and it is inclusive of the 2. So that's the soft bracket, hard bracket for interval notation. And then the next interval is from 2 to 5. It's non-inclusive of 2 or 5. It's open circle on both. So that would look like this. And then the third interval is from 5 to 10. And it's closed circle on both, so that's hard bracket for both of those. Okay? So we already have them written in set notation. Now we can write these intervals in interval notation. So why are open circles used in some situations and closed circles in others? So an open circle means that it is not included in the domain for that function. And a closed circle means that it is included. Okay? How do you know that this is a function? So you could decide that two different ways. One way, by looking at the graph, I can do the vertical line test. All right, so this is a function all the way across because it's never touching more than one point. Even right here or right here, I have an open circle in one section and a closed circle in another, so it's still a function. So vertical line test. And one input still has one output. Now, what is the range of this piecewise function? So the range here is a set of numbers. So instead of it being a set, like instead of it being an interval, it's 15, 25, 30. It's just a list of numbers for the range because there are three different values there. Okay. Now, beat the test. Evaluate the piecewise-defined function for the given values of x by matching the domain values with the range values. So we've done this before, but just to recap, we're putting this domain first. On every one of these, we have to decide where it's going to fall. Which rule does it fall under? So 8, let's see. 8 is not less than or equal to 2. 8 is not between -2 and 4. 8 is greater than 4, which means I'm going to take that 8, and I'm going to say, for 8, f of 8 is equal to -3 times 8 plus 8. I'm going to use this function because it matches this rule. So -3 times 8, -24 plus 8 is -16. Okay, so you have 8 goes to -16. F of 8 is -16. F of -2. So f of -2 is going to be this one right here because it's equal to -2. So -2 is less than or equal to -2, so I'm going to use x minus 1. That's -2 minus 1 is -3. Then I'm going to use f of 4. So for 4, it's not less than or equal to -2. It is between -2 and 4 inclusive. So this right here, I'm looking at 4. So I'm going to use this rule. So that rule is 2 times x, so 2 times 4 minus 1. 8 minus 1 is 7. So 4 goes to 7. Then I'm at 2. So 2 is between -2 and 4. So f of 2, I'm going to use the same rule. 2 times 2 minus 1. 4 minus 1 is 3. So 2 is going to go to 3. -5. So -5 is less than or equal to -2, so I'm going to use this rule. F of -5 is -5 minus 1, which is -6. Okay. And then 0 is between -2 and 4. So f of 0 is -3 times 0 plus 8. So that's 0 plus 8, which is 8. Oh, I'm sorry. I used the wrong rule. 0 is supposed to be 2x minus 1. So sorry. So 0 is between -2 and 4. So we're supposed to use this rule. I was looking at the wrong line. So 2 times 0 minus 1. You couldn't see it anyway. So 2 times 0 is 0. 0 minus 1 is -1. So 0 goes to -1. So we've matched up 8 to -16, -2 to -3, 4 to 7, 2 to 3, -5 to -6, and 0 to -1. All right, last little bit. So complete the following sentences by choosing the correct answer from the box. Piecewise defined functions are represented by at least two functions. So piecewise has to be at least two functions that must correspond to different domain values. Remember, for it to be a function, those domain values cannot overlap. If they overlap, it's no longer a function. When evaluating piecewise defined functions, we choose which equation to use based on the x value, so based on that domain or that input or that x value, and then substitute and evaluate using order of operations. You're going to use your instincts to some degree, but definitely order of operations is what we're going to use here. So now you need to complete the practice for homework.